Reading the brain. So the first study we're going to talk about is the Kamitani and Tong 2005. And what did was that they took voxels of the brain. So a voxel is a small cube-shaped area of the brain, about 2 or 3 millimeters on each side, and they they looked at the brain through an fMRI and gave the subject a stimulus of different different gratings of different orientations, and they measured the each voxel of the response of each voxel to different gratings. And what they found was that different orientations of the grating gave had a different response in the same voxel. The next one is Naselaris et al. And what he figured out here is structural coding and semantic encoding. So structural encodings, and he also studied voxels, and it showed that voxels. He looked at voxels and how they encoded structural characteristics of a scene, such as lines, contrasts, shapes. So more of the physical, the more raw elements of objects, and while semantic encoding model is seen at is he looked at like the meaning and category of a scene. So, for example, in this scene, it's there's a building. So semantic encoding deals with how the computer is going to recognize this as a building. So it knows it's a building. So when he added structural encoding model to artificial intelligence, so this is a target image, and it showed that the most probable image is this, which is kind of far from the target image. But when he combined structural and semantic encoding models, this is the target image, and this is the most probable image that he saw. So it is really not far from the target image. As you can see, there's a building on the left. There's this big space here, seen here, small building, and something obstructing this side of the image. And it shows that the structure encoder alone does a good job of matching the structure of the target image. So as you can see here, there's big space, and everything here is occupied. But it does a poor it does poorly in matching the target image and the target image. And also same with the semantic, but adding semantic encoding to structural coding gives us more an in-depth image. It gives the machine an in-depth perception of the target image, which gives us a more probable image, the most probable image to actually kind of look like the target image. So a combination of both encoding methods help create a better perception machine. So before we move on to one of the last things we're going to talk about, our Facial Special, we're going to play a game. So whose two eyes are these anyway? So he's a celebrity, so I'll give you time to think. Just pause the video. It's Will Smith. These pair of eyes. Pause the video. If you want to figure it out, it's Tom Hanks. If you want that, again pause it. And the last one, Brad Pitt.